Today on Capechi's Corner, we are going to complete some polynomial application problems. If we're given a figure and we're asked to find the perimeter, we know perimeter means we're going to add up all the sides. Now it says find the perimeter of the rectangle, so in this case we know that we have a rectangle, so the opposite sides are the same. So because of that, I know the left-hand side is 3x plus 1, so I can write that on the other side, 3x plus 1. So I found my width, so now I'm going to look at my length. So I have x squared plus 5x minus 1. I know when dealing with a perimeter, I know I need to add up all the sides, so I could write it out as a big long addition problem, but at this point I think it's just as easy just to add up the terms one at a time. So let's take a look at our highest term, which is x to the second power. So if I add those together, I get 2x to the second. If I then look at my x to the first power, I have 5x and 5x and 3x and 3x. When I add those together, I get 16x. When I'm looking at my constants, I have negative 1, positive 1, and then negative 1, positive 1. When I add those together, I will get 0. So my final answer there is 2x squared plus 16x, and that will be units. If it's feet or inches, that's what I would have. It's not units to the second because that's area, or units cubed because that is volume. Now we're going to find the area. Now remember, area is equal to length times width. So my length is x squared plus 5x minus 1, and my width is 3x plus 1. So I need to multiply those. So I can again use either the horizontal or the vertical method. I'm going to use the vertical method, 5x minus 1 times 3x plus 1. So I'm going to multiply 1 times negative 1 gives me negative 1. 1 times 5x gives me 5x. 1 times x squared gives me positive x squared. Now I'll do the same thing with 3x. 3x times negative 1 gives me negative 3x. Now remember, I'm going to line that up with my like terms. So I'm going to line that up underneath the 5x. 3x times 5x gives me 15x squared. 15x squared, that's a positive. And then I'll take 3x times x to the second, which gives me 3x to the third. Now that I have everything distributed and they're all in the right columns, I'm going to add and combine my like terms. So I have 3x to the third plus 16x squared. And then I have plus 2x minus 1. And this time again it's going to be units squared because area is squared. So that's my final answer for the area. Our next problem says the perimeter of the triangle is 21y minus 7. Write an expression that represents the length of the missing side. So remember, we know the perimeter is when we add up all the sides. So we have a missing side. So far we have 2y minus 4 and 7y plus 6. And I'm going to get to 21y minus 7. So I know that 2y plus 7y plus something else is going to give me 21y. So this gives me 9y. So my missing piece right there is going to be 12y. I'm going to do the same thing with my constants. I know I have negative 4 plus 6 plus a number is going to give me negative 7. Negative 4 plus 6 gives me 2. So my missing number there is negative 9. That will get me to negative 7. So in the end, my missing side is 12y minus 9. Now again, it's easy to check this. If I just add up my y's, I have 2y plus 12y plus 7y. That gives me 21y. I have negative 4 plus 6, which is 2, minus 9, which is negative 7, and that's what I want my perimeter to be. Our next problem says, what is the volume of the prism? The formula for volume is length times width times height. My length is x minus 1, my width is x, and my height is 2x plus 5. Now remember, with multiplication, since I'm multiplying three things, I can move things around in a different order. So first I'm going to multiply my x, and then I'm going to do x minus 1 times 2x plus 5. Now I know I have two binomials here, so I'm actually going to use FOIL. I'm going to leave that x there, and I'm going to come back to that. So that gives me 2x squared is my first, my outside is 5x, my inside is negative 2x, and my last is negative 5. So again, if I clean that up a little bit, I get 2x squared plus 3x minus 5. Now I need to multiply x by all those terms. So I have 2x to the third power plus 3x to the second minus 5x. And that, again, is going to be units cubed since we're dealing with volume. Our next question says, what is the volume if x is equal to 3? So let's go back to our diagram. So my width would be 3. I'm going to label that. My length is x minus 1, so 3 minus 1 gives me 2. And my height is 2x plus 5. So if I substitute 3 in there, I get 2 times 3, which is 6, plus 5 is 11. So there's my dimensions. Now, since volume is equal to length times width times height, I have volume is equal to length, which is 2, times the width, which is 3, times the height, which is 11. I multiply those together, I get 66. And again, that's units cubed because volume is cubed. Our last question is, what happens to the volume when each side is doubled? So let's look at our diagram. If I'm doubling it, I'm multiplying it by 2. So my length goes from 2 to 4. My width becomes 6. And my height becomes 22. So when I multiply those, 4 times 6 times 22, I get 528. Now again, that would be units cubed. Units cubed. Now, anytime in math when they're asking to compare, they're almost always looking for not I added 7 or I subtract 6. A lot of times they're looking for does something double or triple, is it multiplied by 1/2? They're looking for a comparison that way. So if I take 528 and I divide it by 66, which was my original volume, so when I divide that, I end up with 8. So what does that mean? Well, by dividing 528 divided by 66 and I get 8, I'm just saying that when I start with 66, if I were to multiply it by 8, I get 528. So why does that happen? It happens because, remember with volume, we're multiplying length times width times height, and we're doubling everything. So we're multiplying everything by 2. 2 times 2 times 2 gives you 8, which is why when each side is double, the volume is multiplied by 8. Now we're going to find the area of the shaded region. So looking at our diagram, we notice that the whole thing is not shaded. We have a part inside that is not shaded. So we basically need to get rid of that. So if I can take the total area of the whole figure and I could subtract out that piece that I don't need, that would give me the area of the shaded region. So remember, area is equal to length times width. So I'm going to multiply 3x plus 2 times 2x minus 1. That will give me my total area. Now I'm going to subtract out the piece that I don't need, which is x times x plus 3. My total area is 2 binomials, so I'm going to use FOIL. So I have 6x squared. My outside is negative 3x. My inside is positive 4x. And my last is negative 2. I'll combine my like terms. I have 6x squared plus x minus 2. Now, I have to subtract out the unshaded region here. I have to be really careful. I'm subtracting, but I have to make sure I multiply this, and I'm going to put it in parentheses to make sure in the end I distribute when needed. So x times x gives me x to the second. X times 3 gives me positive 3x. A common mistake that students make a lot of times is not putting this expression in parentheses and just taking this negative and attaching it to the x squared and not the 3x. That's where we have to be careful. So now I'm going to distribute that negative, so I get negative x to the second minus 3x. And now I'm going to combine like terms. So I have 6x to the second minus x to the second gives me 5x to the second. I have x minus 3x gives me negative 2x minus 2. Now this is going to be units to the second, units squared, because we're talking about area, which is always squared. Our next application problem says a picture frame has a length and a width of the quantities 3x plus 1 times the quantity of x plus 4. A 2-inch frame was added to each side of the picture. Find the area of the frame. So again, let's label this. So I have 3x plus 1 is here, and x plus 4. That's the area of the picture. Now we have to add a frame. So now remember, let's think about this. A frame on a picture goes all the way around. So I'm just going to draw my frame all the way around. And it says it's 2 inches everywhere. So what happens here, like let's look at the bottom. That piece right there is 3x plus 1. We're going to have a frame on either side. So that's going to add 2 inches on either side. So my total length there now is going to be 3x plus 1 plus 2 plus 2, which is going to give me 3x plus 5. Now again, if I do the same thing, and on the other side I have x plus 4 That's the piece in there. And again, I have my picture frame is 2, again, on either side. So again, my whole piece there is going to be x plus 4 plus 2 plus 2. So that gives me x plus 8. And that gives me the width of the entire side, the picture and the frame as well. Now again, you have to read this carefully. It says find the area of the frame. So I really just want the area of the frame. I'm not interested in the area of the picture. So similar to what we did in the last problem, I need to do the total area, and I need to subtract out the area of the picture. So let's see how that works. So my total area, including the frame and the picture, I have 3x plus 5 times x plus 8. Now I'm going to subtract out the area of just the picture. So that gives me 3x plus 1 times x plus 4. All right, back to my total area. I have two binomials, so I'm going to use FOIL. So I have 3x to the second plus 24x plus 5x plus 40 minus, now my area of the picture is also two binomials, so I'm going to use FOIL. Now again, I need to put these in parentheses because I need to distribute that negative sign in the end. So I get 3x to the second plus 12x plus x plus 4. I'll combine my like terms, so I have 3x to the second plus 29x plus 40 minus, I'll do the same thing with my second set of multiplication there with area of the picture. So I get 3x to the second plus 13x plus 4. Now again, I'm going to rewrite my total area, and then I'm going to subtract out my area of the picture. So I get minus 3x to the second. Again, and remember I have to distribute, and I get minus 13x minus 4. My last step is I will combine my like terms. So I have 3x to the second negative, and minus 3x to the second gives me 0x to the second, so I don't need write anything there. 29x minus 13x gives me 16x. And I have 40 minus 4 gives me plus 36. And again, because it's area, that's units to the second power, units squared. Now that is the area of just the frame. Our next question says, what is the value of a that will give you a true statement? So let's see what we have. We're subtracting the polynomials here. We have the quantity of 2x squared minus 11x plus 8 minus the quantity 3x squared plus 8x minus 2 is equal to negative x squared minus 3x plus 10. Now, this type of problem looks overwhelming at first because that variable is kind of messing you up, not really sure what to do with it. But let's just take a little closer look. We're looking at ax, so it's x to the first. So everything else I don't really need to pay attention to. So I have negative 11x minus, because I have to distribute that negative, 8x is equal to negative 3x. Now again, if I'm trying to isolate a, I can really just solve this algebraically. So I'm going to add 11x to both sides. I have negative ax is equal to 8x. And now I don't want that negative sign, so I'm going to divide both sides by negative 1. And I have ax is equal to negative 8x. And I can see my x's are the same. I could divide both sides by x, but I can see my coefficient in the front is negative 8. So I have a is equal to negative 8. That's my value for a. Now I can check this again. I just have to be careful. I'm only going to focus on x to the first. So I have negative 11x. Now again, I'm distributing, so I have minus negative 8x. So I have to be careful there. Is equal to negative 3x. So I have negative 11x. That gives me plus 8x is equal to negative 3x, which is correct. So I know that my correct answer is a is equal to negative 8. Our last problem for today says, what is the value of a that will give you a true statement? So again, we're trying to find that unknown variable a. This time we're using multiplication. So I have the quantity of 4x plus 3 times the quantity of ax minus 2 is equal to 24x squared plus 10x minus 6. So I have two binomials that I'm multiplying, so I'm going to use FOIL. I just need to focus. I have a as my first term. So there's a couple different ways I can do this. I think the easiest thing is let's just use when using FOIL, just use the first term. So I have 4x times ax is equal to, now we know it's going to equal right here to 24x to the second. So when I multiply my first terms together, I have 4ax to the second is equal to 24x to the second. Now if I divide both sides by 4, I have ax to the second is equal to 6x to the second, so I can see that a is equal to 6. Now again, if I want to double check the whole thing like I thought I was right or I didn't feel very confident, I can do that. 4x plus 3. Now I know the value for a is 6. I can multiply that by 6x minus 2, and I'll use FOIL. So I get 24x to the second. My outside is negative 8x. My inside is positive 18x, and my last is negative 6. Combine my like terms, so I have 24x to the second plus 10x minus 6. And when I go back, I can see that gives me the answer that I was looking for. So I know that I have the correct value there, that a is equal to 6.